whereas the average speed is the average of all instantaneous speeds. So, for example, let's just say you're driving to school, and you go for a little bit, and then you stop, and then you go kind of fast, and then you have to stop again, and then you go slow again, and then you stop, and then you get to the part where there's never any cops. So then you go really fast, then you stop, and then you get to school, and then you're there. Your instantaneous speed is what the speedometer reads. So right here, the speedometer might read 5 miles an hour. And then when you get to the part with no cops, your speedometer might read 65 miles an hour. So think of the instantaneous speed as exactly what your dashboard is telling you. Whereas for the average speed, the average speed would equal the total distance divided by time. So if it took you 5 miles to get to school, if your drive to school was 5 miles long, and it took you 5 minutes, then you would do 5 over 5. And it would be 1 mile per minute. Alright? So the average speed is the total distance divided by the time. Now let's talk about velocity. The instantaneous velocity instantaneous velocity, for all intents and purposes, is really the same as the instantaneous speed. It's the speed at any given moment plus direction. Speed at any given moment plus direction. So whatever your speedometer reads plus whatever your compass reads. 60 miles an hour north would be your instantaneous speed. Your instantaneous velocity. Whereas your average velocity equals displacement over time. Notice the difference between average velocity and average speed. I'm going to rewrite the equation for average speed down here. Velocity is displacement divided by time, whereas speed is distance divided by time. One has direction, the other does not. Another way to represent the velocity more commonly is going to be simply v equals delta d over t. This is our first sort of look at our kinematic equations. All right, any questions? Let's take a look at what this actually means. Consider two quantities, speed and velocity. Which quantity is a vector and which is a scalar? I can answer this. So let's work on your name, so bear with me. Connor, what do you think? What'd you say, D? Yeah. Question number 2. Which statement accurately describes the relationship between speed and velocity? Patrick? Ryan?
B.
B. Which one of the following is true of an object that is said to be moving fast? You say an object is moving fast. What does that mean, Albert? See? Yes, it has large instantaneous speed. If you cover a long distance, you could still be taking a very long time to do that, which would mean you're moving slowly. If you've been moving for a long time, you could still be moving slowly for that long time. So it's, see, the object has a large instantaneous speed, whatever the speedometer says. How about this one? How is the speed at any given instant different from the velocity at the same instant in time? What you think, Matthew?
C.
Stops the recording. I forgot about that. It's okay. Same speed value. Which two? Hannah, what you think? Hannah says A and D. You guys agree? Yeah, she's right. Because to get the speed, you do distance divided by time. 4 divided by 10 is 4. 20 divided by 5 is 4. That's the same value. We'll put the next one up. Leanne, what you think? Tyler? B? The correct answer is C. Because now, so we're talking about speed, distance divided by time. For answer D, the distance was 40 miles.
average speed 40 miles.
Yeah.
Just trying to figure out how.
Right. Right. You moved a distance of 40 miles. In example, in answer B, you moved a distance of 40 miles, and the time was 1 hour. So he'd be moving at 40 miles an hour. In C, he moves a distance of 40 miles total. It takes him 2 hours. 40 divided by 2 is 20. So that's why the answer is C. Any questions on that one? This is the same question, but it's asking for the velocity of 20 miles an hour.
There it goes.
B.
Oh,
Oh,
big.
very good.
So that
The
was my
reason
fault.
it's B is because, unlike, so the first time he was telling you this, because we were working with distance. But now that we're talking about displacement, he goes 40 miles, but then it's 20 miles from the starting point. So if you start somewhere and you end up and you're 20 miles from there, your displacement is 20 miles. Your delta D is only 20 miles. And he did it in 1 hour. So that would be 20 miles an hour. Any questions? Number 4, a delivery truck moves a distance of 60 kilometers and is 20 kilometers from its starting point after 2 hours. What is the average speed? Yes, what do you think? Sorry, Jenna. C, yes. Because the total distance is 60. The total time is 2. Distance divided by time will give you speed. 60 divided by 2 is 30. Probably guess. The next one. Delivery truck moves a distance of 60, 20 kilometers. What is the velocity?
So how do I wake it up without making the answer come up?
Oh, that's the problem, huh?
Yeah, because that's what I did last time, and it just
What if you press the top?
you're
Press the
genius.
top.
So
Yeah,
make it where it doesn't-
make it longer. Yeah, I'll do that. But for now, if you just press the top, with not on the. How about this one? Question number 5. Morgan says A. Yes. Because your displacement is 20. You're 20 from the starting point, so your displacement is 20. Your time is 2. 20 divided by 2 is 10. All right. How about this one? Dante, what you think? C? Very good. Here. So let me just explain. This is the first chart we've seen. The question is asking for velocity. Velocity is equal to the change in displacement divided by time. Change in displacement if you start at 25 and you end at -5. So some of you might have looked at the whole thing. Don't waste your time. If you see the word average velocity, you know you're just taking the displacement. 25 to negative 5 is a displacement of 30. And your time is 6 seconds. That's going to give you 5 meters per second. All right? To the left. Any questions?
Can you go back to form?
Yeah.
So I had read it to where like it said it's 20 kilometers after 2 hours, so I got 8 because I did 20 divided by 2 and got 10. So how? Oh, the average speed. Okay, I see.
So yeah, the reason why these questions are worded weirdly is because you could take it as you start somewhere and then you move after 2 hours, you're 20 kilometers from where you were, but then you could have gone another distance. Is that what you were thinking?
Yeah, kind of.
And eventually moving 60. That's what I mean. For a total of 60. That's one way to read it, and that's not the intended way. The intended way is just to get you to see that you had backtracked. The intended way to read it is that you started somewhere, you went about 40, and then you went about 20 back. So that your total distance was 60, but your displacement is only 20. That's how it's intended to be read. Anything else?
That's why they're doing it.
Yeah, it is. Sorry. Okay, that's all I got. So let's open up to the packet I gave you yesterday. On page 3, you have some velocity and speed. On page 4, we have some more average velocity and average speed. And then on page 5, we have instantaneous speed versus average speed. So let's see, how should we do this? I want to give you guys a chance to relax and talk to your neighbors and stuff. So let's just say 5 minutes for page 3, and then we'll go over it. And then I'll give you some more time for page 4, and then we'll go over it. Page 5, we'll go over it. Does that sound good? So let's say 5 minutes for page 3. You can work with your neighbor, and then we'll go over it. Yes, let me get you some.